Hey everybody, welcome back to another edition of Gruber Wired. I'm Mark Beach.
I'm John Dotson, and welcome once again. And today we have a special guest with us. It's Matt from Zippertubbing. How you doing, Matt?
I'm doing great. Thanks for having me out here.
Oh, you're welcome. Thanks for joining us.
Yes.
This should be fun.
We got a monsoon last night, so, it's a great day today.
Yeah, did you get some of that rain by your place?
You know, not a lot of rain, but I was seeing the lightning.
Lightning was pretty impressive,
Hearing the thunder a little bit.
It was going. I think it's going to rain tonight, though, like really rain.
I hope so. We could use some because, like you said, we had a bunch of thunder and lightning, and I'm outside going, "Oh, this is cool," but not a drop of rain. So
yeah,
let's get some of that moisture out of there.
That's all right. I remember many summers of swimming in the pool and everything swirling around and nothing dropping. But it happens. It's summer in Phoenix.
Right. Exactly. Yeah. So, Matt, again, welcome. We appreciate you coming on to talk a little bit with us today about what it is you guys do out there in the world.
Absolutely.
So let's start by talking about you, a little bit about yourself, your background, how you got into this industry.
Yeah, great. I'd love to share. And it was great. We kind of crossed paths a couple months ago and realized how similar Gruber and Zippertubbing really kind of were at the core. But me, Matt Hesselbacher, I went to college down in Tucson, University of Arizona. I know. I think Sun Devil here.
That's all right.
both are excellent schools.
Yes. Okay.
I got my degree in electrical engineering, so right on topic. And out of school, I went to work for Raytheon, so I kind of went aerospace path. It was really a great experience down there. I got to work on some really cool systems there. Got to travel around working on that in part of their radar and RF system design group. That was great.
Nice.
Then following that, I stayed in aerospace and I went up to Orbital Sciences Corporation here in Chandler. So I wanted to move back to the Valley, get out of Tucson.
Sure.
It's a great place, but that's where I'm from. Grew up in the Phoenix area down in Ahwatukee.
Oh, okay.
So moved to the area, Orbital Sciences, working in their launch systems group.
Right.
So that was really great, working with a lot of smart people there, some really cool systems, doing some electrical system design, integration, and actually got to go out to California to do some rocket launches.
Oh, cool.
So that was an excellent part.
Wow.
I bet that was fun.
Yeah. It was so cool just to be there, and I got to be on a launch console for sending stuff to orbit. Well, not or as like a suborbital mission, but it was really cool.
Very cool.
Then after that, I landed at Zippertubbing. It's a company I had never heard of before working there. I think a lot of people haven't heard of Zippertubbing, what it is, what the company is, and I was looking for a change. A recruiter reached out to me, and the rest is history. I've been there for over 10 years. I love it there. I love the culture. I love what we do. It's really exciting. Lots of different projects to work on. And
so is it an Arizona company, or is it headquartered somewhere else and you guys have a office here? Or
it's in Arizona now, but Zippertubbing's been around for nearly 70 years at this point.
Oh, wow.
So it's a family-run business. It was the Plummer family for generations, and in about 2013, it's changed hands to Sean Plummer, who currently owns it. And he had been living out in Arizona, had a couple other businesses in Tempe, so he decided to move the company out here. It's a big undertaking to move all that manufacturing from Los Angeles out to here and then have to restaff with all new people.
Right.
So a lot of learning, a lot of trial and error and figuring out how to do things again because you're, learning how to do this, but also maintaining all these old customers. It was quite an experience.
So you guys are a USA company?
Correct. Yeah. We have our engineering group and our production facility in Chandler, Arizona. We're very proud that we make almost all of our products here in the Valley.
Wow, that's amazing.
That is cool. Yeah, we have a comment up there. I say, go Maryland Tarpons. I'm not familiar with them. Must be the school, huh? I'm all about those turtles. So,
okay, Noah.
Yeah, it's got to be some of our staff having a little fun there. Yeah. So
well, that's impressive. I mean, certainly we like to promote USA made to begin with, but Arizona made's even better.
Yeah.
We're kind of proud of what we do here, and we have everything, soup to nuts. I mean, we do metal manufacturing. I'm sure you've seen that already. If not, we should take you on a little tour. But the server racks, shelving, wire managers, lacing bars, rack rails, all that kind of stuff, made right here on the block. You know what I mean?
And we get into our cabling products, right?
Right.
And that's where you would, business would come in and your products would be coincide
Right.
exactly with what we're doing and just kind of marry each other.
Yeah,
Right.
one of the main reasons why we notice so many parallels between Zippertubbing and Gruber is that building things in the USA, in the Valley, we're doing some of the extrusion even in Tempe of the track from some of our products and then putting it together in
Okay.
Chandler with the shielding or thermal protection,
Right.
and then shipping it out.
Fascinating.
Yeah, it's amazing to me. So let's get into some of the meat and potatoes. Talk about some of
Yeah.
the products offerings that you're bringing to the table and maybe educate people a little bit on what it is you guys do.
Yeah. So Zippertubbing back in the 50s started out doing cable protection. So
Okay.
it was the plumber manufacturing companies really dated back almost over 100 years, but Zippertubbing, that company was a spin-off in cable protection. It was flexible PVC with an interlocking track system.
Okay.
So it started off as that, and then it branched off into a lot of other products and categories that are near that.
Sure.
You've got a cable, you want to protect it for abrasion, but also for thermal. Maybe it's going to see some EMI shielding, so now you need to protect that cable that way. And
Right.
all these different projects that over the decades, Zippertubbing has taken on and added as part of our portfolio.
Wow. Yeah, especially I guess coming from the aerospace industry, you probably see a huge need for that.
Sure.
Yeah, and that's been a big benefit for my background is being an electrical designer, an integrator for aerospace companies. I can understand what these people are looking for, those other
Right.
engineers that are coming to us with problems. I was there. I was in your spot. and I'm very happy to help them with that.
Very
That's
cool.
Good stuff. So we got some photos that we're going to go through and some
that's
little
right.
videos
Yeah,
and
yeah,
take
yeah.
a look and see a little more about you.
I thought a great thing to talk about today would be EMI, electromagnetic
Okay.
interference. That's
Sure.
a very common thing that people come to us with questions because it's difficult to deal with. If you're dealing with abrasion protection, that's kind of easier to deal with and understand. Even if you're protecting something from high or low temperatures, also easier to grasp that. But electromagnetic interference is a little bit more daunting. And you talk to any engineer who's worked with that, it can be very challenging to troubleshoot, to figure it out, to
Some
find your
wizardry
problem.
involved. Sure.
They'll
Yeah.
say it's black magic, some
Yeah.
of these things.
Yeah.
It's really tough. So we had put together a webinar for Zippertubbing where we could kind of educate our customers, where we could
Okay.
talk about EMI, what it is, some common troubleshooting steps, and then kind of things you might look to as a solution for those problems.
Sure.
Because we were answering this question weekly, daily
Right,
to our
right,
customers. So
right.
it's a good resource. We taped it and then we have it on YouTube that people can look at so they can
that's-
reference it.
And talking about that, you're saying you're getting people coming in weekly with these questions about it. So it's a bigger problem than what we might recognize.
Yeah, absolutely. You guys talked about it last week, I think, is just technology that's becoming obsolete
Yeah,
and the new
correct.
things that are coming in. And it's more systems that are maybe they were mechanically driven in the past. Now they're electrically driven. People
Sure.
are getting smaller. There's wireless Bluetooth everywhere. So you've got more sources of EMI, and you've
Right.
also got more smaller, maybe sensitive electronics that could be susceptible to it.
Right. It takes less to interfere with it than it would something more robust that maybe was built at a different scale at a certain point in time. Right.
Yeah.
So yeah, totally understand.
Yeah, Gruber Motor Company. That's Pete Gruber, the owner of Gruber Industries here. Says, great guest. Thanks for coming out and contributing to our podcast.
Yes.
Again,
You know?
thanks for having me out here.
So yeah, let's get into some of this. What do we have?
Right. So if you want to go to picture 3, I think that's a good one to start with. So when you're talking about EMI, we really see 2 types. You can break it down into 2 types. It's electric field or E field interference, and then magnetic or H field. So they're really part of the same thing, but you would think of them different and attack those problems differently. So
Okay.
electric field, we kind of like to think of that as like analogous to a ripple in a pond. You throw a stone in a pond and you see the ripples, they kind of radiate out from that source. They kind of go a longer distance. And if you know the frequency, those are usually middle to higher frequencies, megahertz to gigahertz frequencies. You'll see those electric fields causing problems. And then the other one, magnetic field, you're thinking of magnets, right?
Sure.
visualize that pretty easy. That's lower frequencies, megahertz down to kilohertz and even hertz. You get the magnetic fields. And like with a magnet, it's strongest close to the source. It's going to have the most interference at that source, and it kind of drops off much faster than an electric field.
Okay.
So those are kind of the two types and what we'll be talking about.
Great.
And these things they're constantly moving, right? And changing as you go through the process. Like, I know that, take the Earth's magnetic field, like it rotates and polarizes every so often. So is that the same in a smaller aspect? I'm just curious because I don't know.
Yeah, it's really tough to think about. And usually if it's caused by a cable or something, then it's going to be consistent with that cable. But you can have reflections off of different things, or the magnetic field can be interfering with different metals, or even reflections of that signal from your own system. So very hard to pin down because there's so many variables.
Yeah, that's
that
why I was curious about this. Yeah, wild.
Yeah, absolutely. Let's go to picture 1. So this is something that we go through a lot with those customers, is the troubleshooting. And that's to help determine if you're dealing with an electric field or magnetic field issue. So usually it's one or the other. It could be both if you've got a lot of problems, or your system's very complicated,
Right.
or you've got a very large system, or you're in a noisy environment, or you have very sensitive components. You might have to tackle both.
Now, just quick question. How does it manifest? Does it result in like packet loss? I mean, how does it show up at the end user? Degradation in bandwidth? What is it? How does it show itself?
Yeah, it can manifest in a lot of different ways.
Right.
If you're talking about communication cables or communication systems, it could be a packet loss. It's enough noise on that frequency you're caring about that it could flip a bit, or it could read a bit when there wasn't one. You could lose packets.
Okay.
If it's an instrument that's measuring something like noise, or a strain gauge or something where you're trying to measure very precisely, but you get little spikes or blips of energy, it can throw off your reading, especially if you're talking about a scientific instrument or something that needs to be very precise.
Yeah.
Sure.
A small little bit of interference
Right.
can cause big problems.
Okay. Thank you.
Yeah. So the first thing you can try and find is it cables that is causing your problem? Is it coming into a cable? Because what is a cable? But it could be a big antenna to pick up this interference.
Right.
Yeah, look at our desk here.
So it can be conducted through parts of your circuit, but oftentimes it's in a cable. They're usually one of the major culprits of that interference getting in your system. So you can look at your system, see if there's any high power components. So this is very common. Someone has a high power motor, or maybe a high amp circuit that has these power cables that are running near signal cables. And that's going to be a big culprit for magnetic interference. That's going to cause a big magnetic field.
Okay.
And what you can do is you can move those cables around. Like I mentioned a moment ago, is the magnetic field is strongest at that source, but it drops off pretty significantly with distance.
Okay.
So if you can reorient your cables so they're further apart, or if they do need to cross, if you can cross them at 90 degrees, it's not going to couple the magnetic field into your cables. So we'll tell people, all right, if that's what you think, if you have a high power source, just move the cables around, see if you notice any improvement.
Okay.
And oftentimes that's all it takes. You just move the cables around.
And that's it. There's something so simple.
It can be as easy as that. And I'm not going to sell them anything, but they solve their problem. So
Yeah, right.
Well, I'm sure we've all
Very
heard it before, because you have RF hum like on microphones, and mic cables that might be running adjacent to power cables, or I've done sound systems, so I've kind of run into it where unintended, you're running it along what you think is a good track, but subfloor or somewhere along that track is electrical, and
Just picks up on that.
yeah, you get the RF hum on there, and you either noise gate it or fix it.
yeah.
Yeah.
The other troubleshooting step that we'll say is just you can use aluminum foil or foil tape is a great way as a first step to see if it's electric field. So if you're moving your cables around and it's not fixing it, you can try wrapping them with foil, and that's going to be like a makeshift shield for that electric field. And if that's yielding some improvement, or you notice your signal's getting better, you're dropping fewer packets in a communication system. All right, maybe now I'm on the right track. It's an E-field problem that's causing
Gotcha.
this issue.
Right.
So something as simple as aluminum foil, and you
Yeah.
can determine what your issue is from there.
Yeah, and it's not even for someone dealing with audio equipment. We've worked with aerospace, military customers with multi-million-dollar systems, and they're wrapping foil on it to troubleshoot and find out where it's coming from.
Wow.
Yeah.
Wow.
Let's go picture 2.
Because science is fun,
I love science. I'm a big fan of science. Who isn't?
right?
Yeah. So once you've done the troubleshooting steps, you can move on to working on a solution. So if you've identified it's an electric field, you can attack that kind of 2 ways. Mostly we see conductive materials. So this is going to be metal braid or mesh or even foil. Those reflective conductive materials are going to reflect the electric field away. Won't let it attack your cables. The other thing you'll sometimes see is absorptive materials. So those are polymers with carbon in it or some other material that's going to absorb, kind of turn that energy into heat and knock down the signal a little bit.
So it dissipates it through absorption.
Right. Rather than reflecting it, it's going to take those
Eat it.
signals. Yeah, eat it. Pretty
much, yeah, right?
That's a good way to think about it. I like that. Yeah. And then if you've got a magnetic field, if moving the cables around was yielding some benefit, you could just do that. You could reroute your cables, simple as that. But if you did need to shield it, you would use some ferrous metal that's going to reroute and redirect that field before it can get to your cables. So steel's a great option. There's other options of high nickel content metals that you can use to redirect that field, but steel's works fine, readily available.
Right.
It's a good option. And then you're going to balance that with other things that might be involved. Maybe you've got weight constrained, or maybe you need something that's going to work well outside in the elements. So you might want
We
to
just keep going, right?
Yeah.
Yeah. So,
you might want to choose your shield based on that.
okay. Makes sense.
Is
Now, is there,
Is it still recording?
I'm sure we're still live, aren't we?
Yeah, we're still live.
Okay.
Okay.
Yeah, a little technical difficulty inside here. So,
Okay.
but so I got a question for you then. Speaking of strictly that, is there any difference whether this is taken, the situation is indoors versus outdoors? Is there any disruption or difference there? Is it just
You can have the interference anywhere. There's
It's environmental,
plenty
I
of
guess.
sources,
Yeah,
and they
right.
can. It's not the magnetic field is going to be more localized, but the electric fields can be miles
All
away. Your
throughout,
source can be and that's going to affect it. Maybe indoors might be better because the structure of your building might be
Might
actually
shield a little
shielding
bit,
some of that signal.
That's why you don't want to have high voltage power towers in your backyard.
like those?
Yeah. Right.
Yeah, I don't want to scare anyone out there by that, but let's see. Let's go to picture 5. Yeah, so this is a screenshot of something we did in the webinar, which was a visual demonstration of how you might pick a shielding material to attenuate those electric fields. And the way we like to think about it is visual, to break it down, because EMI is kind of hard to grasp sometimes. So
Right.
we had this demonstration where we've got different size spheres, the red being lower frequency, which correlates to longer frequencies. The blue would be higher frequency, so that's lower wavelength because they're inverse to each other. And then the white one's somewhere in the middle. So you might choose a shield based on what frequency you're trying to protect against.
Okay.
So in our webinar, we had set up a little demonstration. So if you could play the first video, this is part of it where we have this set up where we kind of show a demonstration visually where you can kind of see how I am.
And we won't get audio in the studio from that here, but it goes out over the.
Yeah, so you see the red balls, the low frequency ones were caught in the top, the blue ones at the next level.
And they dropped on down.
Yeah, and then they get blocked by the different progressively better shielding materials.
Now, a question: is there the shielding materials? Are a lot of these universal to all 3 of these steps? I mean, I understand it's geared towards low range frequency. You can get this particular shield, but is there one that covers all?
Yes. Basically, so a material that's going to block your high frequency, your smaller wavelengths will typically block everything.
So it's like reverse
Lower than it.
compatible. Then.
Yeah, it'll block the lower frequencies. It'll do a good job, but the ones that are good up to a certain point, they're not going to shield the higher frequencies. So you can think about it like the balls. If you have that shield that's got openings in it, like a braided sleeve or a mesh, some of those smaller frequencies can make their way through. We like to think about it sometimes like fish and nets. So if you want to catch small fish, you need a net that's got really small
tight.
openings.
Yeah.
If you're just catching big fish, you can get away with a big net.
Yeah, makes sense.
Let's see. And then picture 4, please. I think that's a good one to talk about now, because this is a typical shielding effectiveness graph talking about frequencies and what material you might choose. So when you're looking at it, what material to choose, you might see a shielding effectiveness graph that's laid out like this, with frequency on the horizontal axis, and you've got your shielding effectiveness in dB typically on the vertical axis. So you can pair it with, and if you knew what frequency of concern you had or where you're having your problem, you'd want to make sure the material you choose has an appropriate level. And then we've got the tip at the bottom for dB measurements. Maybe not everyone's familiar with dB measurements, but every 3 dB is a halving of that energy. So when you see a level that's maybe 60 dB, that's not a 60th. It's actually like 1/1,000,000th of the energy, because it's a factor of 10 every 10 dB. So when you have a shield that's blocking 60 dB, that's a tiny, tiny fraction of the energy that's left over.
Right.
Interesting.
Is Lucy Bell one of yours?
Lucy Bell?
Yeah, I
Lucy Bell
think
did that.
I love the visual thing. We talk about electricity and EMI shielding in terms of water, because you can visualize it. Just thinking about radio waves is, you can't visualize it.
Yeah, thanks for joining us, Lucy.
Yeah.
All right, and hey, that's just a quick reminder. If you're watching live, make sure you pop comments in. It's the only time when we can answer you live, so jump in if you got anything.
Yeah. The last thing I have is
the reason I want to give people the why too. The reason we're talking about this is that you produce tubing, the wraps that have EMI shielding in them. So not only do we have shielded cable that customers will specify, whether they want an outer shielding or the twisted pair shielded inside, or all of the above, but then the wraps itself can be shielded, right? So that the entire cable is completely protected from anything, right? At that point.
Exactly. Yeah. If they've specified shielded twisted pair for the cables that you guys are making them, great. But if they had said, unshielded is probably fine, then they run into something. Then they run into an issue. That's where Zippertubbing comes in. We have the wraparound jacketing that has shielding in it, and you can solve your problems that way rather than going back and having to redo your whole cable.
Correct. That's the key right there.
That's beautiful.
Your infrastructure is already in place. All you're doing is an addition to it. You don't have to take it out and wait for the new one to come in. And go through all that. So that's handy. That's nice.
That saves time, saves money.
Yeah.
Very handy to have. The last video I wanted to bring and show was the second video for the frequency analyzer. So this is something that we like to play around with for pre-compliance, and we have a signal generator and a little receiver, so we're able to actually look at different frequencies and see that in real time. So we have a demonstration with a little shielded box that we had made for a customer, and so we're generating a signal on one of the devices at 300 megahertz, just a frequency that's common for E-field interference. And then we're putting it in the shielded enclosure, and you can see that signal drop down on the receiver that we're displaying on the laptop.
Oh, that's great.
So it's a great thing. We love to take that to trade shows with us to kind of show it off.
Nice visual,
Yeah,
because you don't realize how big of an effect just adding that conductive shield on your system can do that.
Sure.
I think that spike of energy was 40 or 50 dB, and oftentimes that's enough to to drop it down from it being a problem to not a problem.
Resolved. Yeah.
Yeah.
Wow.
Wow.
People love that visual stuff. I mean, all the technical jargon sounds good to some, but most people go, ooh,
Because at the end of the day, we're talking about something that you can't visualize unless you put it in those terms, right?
Yeah.
I mean, I can't look out here and see a magnetic field. You need to take a reading somehow.
Yeah.
Right.
So having those visual effects is great. What we got there? Janie says, "Hi, Matt. Thank you for joining today. Melissa
Welcome.
Martinez, ZD team is watching."
Oh, that's the people back in Chandler. Yeah. I
Yeah,
told them I was
there
coming
we
over
go.
here
Hi,
next.
Chandler.
Yay, Chandler.
Yeah.
That's cool.
Yeah, they're excited for
fun.
me to come out and join you guys.
It's fun doing this. I'll just take a break for a moment from what we're talking about. But yeah, doing this is fun because you get to help educate people.
Right.
You get to get out there and get in front of people and just, if we can just help educate a few people along the road, especially in a subject like this.
Right.
Because there's possibly someone out there, I guarantee there's probably someone out there is watching this going, hey, this is ringing a bell. This is, I'm having some of these issues.
Exactly. And you had mentioned before the show that you guys had put together some videos on your YouTube channel that were demos or explainer videos, basically, right? So make sure, what's your website?
Well, it's zippertubbing.com. So that's
Okay.
a great place to go. We've
There
got
you go.
all our products. We've got lots of blogs and articles that people are asking us questions about. And then on YouTube, if you search up Zippertubbing, I'm sure you'll find our page with some of those videos.
Do you have a
and-
link on your website to your YouTube or no?
Yeah, all over the place.
Okay,
yeah.
okay, there you go. So, yeah, visit their website and definitely check them out. That's for sure. So we talked a lot about the EMI stuff. Just real quick, what else do you have? I mean, it's not just that. Obviously, that's an important big
Yeah.
one.
Yeah.
But you do a lot.
Yeah,
So
yeah, we do everything that's involved in protecting cables and harnesses and components.
you talked
over the
about
decades.
thermal, right?
Yeah, I'd love to come back for another half hour and talk about all that
Yeah,
other
we
stuff.
could do that.
Yeah.
Seriously, because a half hour goes by fast. If you folks haven't noticed watching out there,
Yeah.
it just, you just scrape the surface and there's so much more there.
Well, then we will have you back.
yeah.
How about that?
We'll have some time to come back and touch on some of those other products and educate people on some of those other issues.
Yeah, the EMI, that's my background in electrical engineering.
Right.
So I usually deal with the EMI issues, but it's thermal protection, it's protection from abrasion, chemicals, fluids.
Sure.
Anything that could harm a cable.
So a lot of harsh environment type of stuff.
All the
It
time.
sounds like, yeah. Which I imagine that's never ending out there, especially in today's day and
Right.
age.
Exactly.
In every
you know?
industry too, like you guys, it's wherever cables are used in medical and semiconductor, aerospace, it's
Shipping. Yeah. I mean, we run into
everywhere.
boat stuff, and that's, those are very specific when it comes to shipboard stuff. And I'm sure you have, like with cables, we have plenum. And I don't know if the tubing is rated the same way, where if it burns, it has to burn with, no VOCs, emissions and things like that. But that's stuff we can talk about too coming up.
Yeah, everything, because there's no real requirements centered on jacketing, so we often lean on the cable specifications. The cables
Right.
need to be plenum rated,
Gotcha.
so does our jacketing. Same
Okay.
kind of requirements.
Sure.
Yeah.
Great.
Do you know Terrell Rollins?
That's not.
Hey, well,
someone I'm
Terrell,
familiar
thank you for watching. Just didn't know shielding is so complex and fun.
Yeah, there's a lot to it for sure. And any given day when we're talking to our customers, you would get a good impression of how important it can be to an operation, and just making sure end to end they have a quality signal, which is the objective of connectivity, right?
Yeah,
Is
exactly.
just getting from point A to point B cleanly. So that's where we are.
Yeah, and if you're out there watching, don't forget that you can also reach out to us at wired@gruber.com,
Right.
and we can get you in touch with Matt. So if you're out there watching and you have some questions that come along, even if you're somebody, I guarantee you, somebody watching today is going to sit there at home tonight and take some tinfoil and go, I think I figured this out.
I hope they do.
They used to use it for rabbit ears, so I'm kind of that perplexes me a little bit, because if it reflects it,
Why was it attracting?
Why did it work?
Or were we reflecting one and attracting another? Is
Well,
that a scenario?
Like I said, your cables act as antennas. A
Yeah.
big piece of conductive material is going to pick up those signals.
There you go.
It's the importance
Okay.
of grounding your shield.
Mystery
That's where
solved.
the difference is. So that's a subject for another time.
There you go, mystery solved.
Yeah.
Well, we appreciate everybody being here today. It's always an honor. We're here every Thursday at 3 p.m. Arizona time. Please like, subscribe, and share this podcast. We're only here because you are. For now, I'm Mark Beach.
I'm John Dotson, and Matt, thank you
Thank you,
so
Matt.
much
Thanks
once
again.
again. And I guarantee we'll have Matt back out if he'd like to join us again.
Anytime.
I think there's a lot more subject matter that people would appreciate to hear about.
Absolutely.
So thank you.
All right.
Appreciate it.
Cheers.